Okay, we have the table below shows the concentration of a dangerous chemical in the blood of an accident victim at various times after an injection was administered to neutralize it. Okay, so there's some dangerous chemical in his blood. We've put some injection in to make it not so bad. So the chemical concentration, you can see, decreases as time goes on. So part A says draw a scatter plot of C against T. Okay, and that's what I've done here using Excel. All right, and draw a scatter plot of ln C against T. Okay, so there's my three variables. I've got time, the concentration, and the natural logarithm of the concentration. And when we do the natural logarithm of the concentration against time, it appears linear. Why is the model connecting C and T exponential? Well, the answer is because ln of the concentration, the natural logarithm of the concentration against time is linear. Okay, so because this is linear, we can assume that this one up here is exponential. Okay, and it has an exponential shape anyway. Find the equation of the line of best fit connecting ln C and T. Okay, so this is just doing some basic operations, finding our equation of a line. Okay, so what we have at the moment is ln y. We're trying to find the equation of this line here in this function. So the way we're going to do that is we're going to say ln y is equal to mx plus c, okay, where m is the slope and c is the y-intercept. Okay, so all we have to do is choose two values on this line to determine the slope and put it into the slope equation. So we might just go with the first two. Okay, so the first one here and the second one here. All right, so we have when x is 10 and 20, so y is 3.59 and 4.65 respectively. So the slope formula is y2 take y1 on x2 take x1. So let's say this is x2 and y2. So what we're going to have is 3.597 take away 4.650, and that's divided by 20 take 10, which is just 10. Okay, so I'll put that into my calculator, and that's going to be our slope. That's going to be our m value. So we have 3.597. Now, actually, what I might do here, just for the sake of accuracy, I might put in the natural logarithm. So the way we came up with that number 3.597 is we did the natural logarithm ln of 36.5. Okay, so I might just do that instead of the so ln 36.5 take away ln of 4.65, ln of 104.6, and that's divided by 20 take 10 is just 10. Okay, and the answer we get is minus 1.05, and we do expect the slope to be negative because it's decreasing. Okay, so the slope we have up there is minus 0.105. So I'll write that one in here. So now what we have then is we're starting to develop this equation. We've solved m. M is the slope. So we have ln y is equal to minus 0.105 plus c. Now the way we're going to solve c is just by choosing 2 points along here. Sorry, 0.105 times x, isn't it? Yep, 0.105 times x plus c. And the way we're going to solve ln y is just by choosing any point where we have an x and y value. So when t equals 30, if we just choose the next one up, doesn't have to be, doesn't matter what we do. When t equals x equals 30, ln c equals 2.54. Okay, so let's put that in here. We're doing ln of 12.7 is equal to minus 0.105 times by, now the x that we've chosen in this case is 30, so we're using these two numbers here, 30 and 12.7, and plus c. Okay, so c is just going to be equal to ln of 12.7 plus 30 times 0.105. Okay, and that's a plus because I've just moved that over to the other side. So this is one we can do in our calculator, and I'm going to do it by keeping these numbers as many digits as they are, just for the sake of accuracy. So what we have is we have ln of 12.7 plus, now in brackets here we just go shift answer, and it's going to bring up that number there, times by, now the answer they give me there is minus, so I'm going to put in here minus 30 just to make it a positive. And that's equal to 5.7. Okay, so our C is equal to 5.7. So now we have this equation here. Ln y equals minus 0.105 times t, or x, plus 5.7. And this is what we use for part D, where it says to find the exponential equation connecting c and t. And the way we do that is by using our laws of logarithms. Okay, so what we're going to do is put e to both sides. So we have e to the power of ln y is equal to e to the power of minus 0.105 x plus 5.7. Okay, now using our algebra skills, that's going to cancel, so we have y is equal to e to the power of minus 0.105 x, and we're going to use a indices law here. Basically, if we have a to the power of m plus n, we can write this as a to the power of m times by a to the power of n. So this is going to be times by e to the power of 5.7. And of course, e to the power of 5.7 is just going to be a number for us. So what we're going to have is y is equal to e to the power of, actually I'll calculate the number and we'll put that first because that's how we like to write it. So we have e to the power of 5.7, which is equal to 298.87. So what we have down here is 298.87 times by e to the power of minus 0.105 x. Fantastic. Okay, for the last part, it says the victim is considered safe when the concentration is less than 0.01 units. Okay, so we're going to have 0.01 here is equal to 298.87 times e to the power of minus 0.105 x, and what we're doing is we're solving for x. Okay, so we're going to divide both sides by 298.87 to get rid of that. Okay, so now we have 0.01 divided by 298.87 is 0.003345. 0.00346, right? And this is equal to e to the power of minus 0.105 x. Now we want to get rid of the e, so we apply the natural logarithm to both sides. So we're going to have ln, I'm going to go up here, ln of 0.00346, and that's equal to ln of e to the power of minus 0.105x. Okay, and that part's cancelled, so we have minus 0.105x is equal to, and we'll calculate the ln of this number, ln shift answer minus 10.305. Okay, and then it's just a matter of dividing both sides by 0.105. Okay, and so we have x is equal to, divided by, okay, 98.14. All right, and what it's asking is, it says it'll be safe when the concentration is less than this. Okay, so at 98.14 minutes, the concentration is at 0.01, so it needs to be greater than 98.14 minutes. So an appropriate answer might be 99 minutes.